Question 2. Part 1 says, state what information in the question tells you that the tension is the same throughout the string in this little pulley system. And the answer is this smooth pulleys. And also, it's a light string. The most important part of that answer is the fact that they're smooth pulleys. Part B. What information tells you that the magnitudes of the accelerations of the particles at x and y are the same? And that's the fact that the string does not stretch, so it's an inextensible string. Moving on to part 2. Draw a diagram showing the forces acting at x and a diagram showing the forces acting at y. So we have a particle at x and we have its weight acting downwards, which will be 2g newtons, and then we have this common tension throughout the string, which we'll call T, which is pulling upwards. For the particle at y, again we have the weight acting downwards, 4g newtons, and we have this common tension throughout the string, T upwards. Moving on now to part 3. Write down the equations of motions for the particles at x and y, hence calculate the values of T and the acceleration A. Now at this point we need to look at this diagram here. What would happen when this was released? Because this is a 4 kilogram mass and this is a 2 kilogram mass, the 4 kilogram mass would accelerate downwards, but the 2 kilogram mass would accelerate upwards. So it's useful to mark on the accelerations on these diagrams. And to do that we usually use a double-headed arrow like that, so we sure that it's not getting mixed up with a force. And on this one would go upwards, double head there, same acceleration A. Now then, the equations of motions. For particle x, it's going in that direction, so that means that T would be bigger than 2g, and the equation of motion F equals ma, as always, so it's T minus 2g is equal to, and the mass is 2 kilograms, so that becomes 2a. For the particle at y, F equals ma again, but this time it's accelerating downwards, so the 4g is bigger than the T, and we have the resultant force is 4g minus T is equal to 4a, mass times acceleration. So there's the two equations of motion. We now have to solve these equations to find out what T and A actually are. So let me call this equation 1 and this one equation 2. The easiest way to solve these equations is by eliminating the T. I have plus T in this equation, minus T in this equation, so if I add them together the T's will disappear. So equation 1 plus equation 2. The T add the minus T disappears, but I've got 4g add minus 2g, which is 2g. And that's equal to 4a plus 2a, which is 6a. So A is equal to 2g over 6 or g over 3. Now at this point we can put in that A is equal to 9.8 divided by 3. Since we've taken g to be 9.8, meters per second squared. And to 3 significant figures, that comes to be 3.27 meters per second squared. Now to find t, we're going to substitute a into one of these two equations here. But you're likely to get rounding errors if you use 3.27, so stick with g over 3 until the final calculation. So substitute for a in equation 1, and we get t minus 2g is equal to 2 multiplied by a, which is g over 3. Taking the 2g to the other side, t is equal to 2g over 3 plus 2g. So t is equal to 2 multiplied by 9.8 divided by 3 plus 2 multiplied by 9.8. And when we feed that into the calculator, we get a tension of 26.1 newtons to 3 significant figures.